Okay, how's everybody today? Doing good. All right, all right. Just a few reminders. Remember, tomorrow is the 13th. That's when your rough draft is going to be due. Please, get that in to me tomorrow. Even if you're going to be absent, go ahead and send that via email. I'm taking the day Friday to grade them. And speaking of, because I won't be here Friday, there's not going to be any tutorials in the morning. Okay, so if you are wanting to retake the exam from last week, you have until Monday morning. I went ahead and pushed that a little bit ahead. Today, I'm hoping we should be able to get through this particular lesson. If need be, we probably go a little bit into tomorrow, but the plan for tomorrow is I'm going to go ahead and give you the homework assignment. It's going to be due on Monday. You'll have the period to go ahead and work on the assignment, but while you're doing that, I'm going to call you up one at a time, and I'm going to help you figure out what your semester average is. Okay, and then next week, we will... Maybe, I'm still kind of debating whether or not to move on with the next lesson, but I do want to go ahead and take a couple of days to review for the final because it's a 50-question review. And speaking of which, you'll get that on Friday. The substitute is going to be left instructions to pass that out for you. Yes?
Will the rough draft, will that be a grade for this 6 weeks?
This 6 weeks, yes. So you have, let's see, that rough draft. You'll have the homework assignments. I think that's pretty much it for this 6 weeks. Okay. All right, so that is the plan. Are there any other questions? Eli.
When do you anticipate having the rough draft graded?
As soon as I get them graded, I'm going to go ahead and start putting them in. So, I mean, I'm taking the entire day Friday, and probably the last thing I'm going to do before I leave is start putting in the grades that I've got. It really just depends on, as I get them graded, I'm going to go ahead and get them put in. We'll kind of see how many are turned in, how many I'm not able to get to by the end of Friday, and I'll just continue that through the weekend. But I'll definitely try to get those back to you as fast as possible. Okay. All right. Hey, Gabby.
How many pages should the rough draft be like?
I'm thinking maybe on average 5 pages. I'm not thinking anything huge. How many you got 13 pages on yours? Mm-hmm. And that's okay. Like if a graph takes up an entire page, yeah, that's fine. Yeah, oh yeah. That's fine. Oh yeah, that's fine. That's fine. Yeah, okay. So I'd say if we're talking just in terms of writing, about 4 or 5 pages, 6 max, yeah. Okay. So Haley, how many of your pages is it all writing or mostly graphs? Okay. Cool. All right. Well, good. All right. Well, let's go ahead and see if we can wrap up arithmetic sequences series today. Let's see. We introduced this topic yesterday. A sequence is a set of quantities arranged in a definite order. Now, we know we're dealing with arithmetic because we're going to be adding or subtracting a consistent value over and over again to generate the sequence. In fact, that's what we refer to as the common difference, and that variable is d. So here, we know that u sub n represents the nth term, u sub 1 is the first term, so that subscript is the value of n, and it's the term number that you're going for. All right, and we worked through several problems based on this formula right here. If you want to find the nth term, we also worked backwards and found the common difference and found the first term. I think we stopped yesterday with this. Okay, so we're going to go ahead and start with how to do these on the calculator. So I won't go ahead and read this word for word, but I'm just going to go ahead and show you how to do this. If you want to generate a sequence very quickly, for example, let's say we have this sequence here. 5, 12, 19, 26. I mean, what would the common difference be? Yeah, you're just adding 7 over and over again. So you can absolutely do this by hand, but let's say you have the technology, which is going to be the case on your paper exams. So I go over here to my calculator. All right. So I'm going to type in 5, okay, because that's the first term in my sequence, and I'm going to go ahead and push enter. Okay. And now what I'm going to go ahead and do is I'm going to add that value of d. I'm going to add the common difference. So I'm just going to say plus, and it's going to connect it to that 5 I just typed in, plus 7. But now what's really neat about this, I push enter, but all I have to do is keep pushing enter. And it'll go ahead and generate that sequence for me. So enter enter, enter. It'll automatically just keep using that previous operation that I put in. Okay. So I could, very quickly get quite a bit of that sequence generated. Okay. Does that make sense? Okay, so that's one way you could do it. So if you're looking for, say, the nth term, say on a paper exam, I still would encourage you to go ahead and write the formula, show your substitution, but then you could probably just go ahead and do something like this if it's a low enough number. If you're looking for like the 100th, probably go ahead and use the formula itself. Okay, let's see what else we got here. Okay. Then down here, we have another example that's already worked through for us. It says an arithmetic sequence has a first term of 120 and a 10th term of 57. Find the 15th term. Okay. So it goes through the algebra and it shows you how we go ahead and find the common difference. -7 is going to turn out to be the value of D. So if we go ahead and plug it in, if we don't look for a specific term, if we keep n as is, then we can actually come up with an expression that can find me any term that I want immediately just by simplifying it. In fact, does anybody recognize what kind of form that is? That's mx plus b, so slope-intercept form, okay? Because we're just talking arithmetic, right? And that makes sense because our slope would be that value of d, and it's always consistent. It's always going to remain the same. So they ended up here with 127 minus 7n. Okay, and one that they're finding is the 15th term, right? Well, let me go ahead and run through some of the ways on the calculator that you could go ahead and find any term number that you wanted. So I'm going to use this simplified expression that they had. But even if you plugged it in like this, you're going to have to use x. The calculator won't show you the simplified version, but it'll still give you the appropriate graph. So let's see here. I'm going to go to my graphing screen. So 127 minus, I believe it was 7. We'll just have to put in x. Okay. All right. And then, of course, we're not going to see it on our standard screen because what's the y-intercept? 127, so it's way up there, right? So you could go ahead and do this, and there's different options, but if you go to Analyze Graph, Windows Zoom, you can just go to Zoom Fit, okay, and it'll fit the screen to your graph. Or in just a second, you can go ahead and zoom out. That's also another way, or you can change the window. But if you see the graph now, if I go to Menu and I want to trace, okay, Graph Trace. So now all I have to do is go ahead and type in whatever term number I want, and it'll automatically go ahead and find it for me because it's a linear function. Like, for example, the 15th term, if I go ahead and type in 15 and push enter, see, it does confer that that is 22. Okay, and I can find anything I want. Let's say I wanted the 8th term. So if I type in 8, okay, there you go. The 8th term is 71. So that's another way to do it. You could trace on the graph. Okay. Another way was, let me go ahead and document B out here. All right. Now I'll just go ahead and type that in very quickly. 127 minus 7x. Okay. So I'm going to see the graph. Let me go back and now hit Menu, Windows Zoom, Zoom Fit. But now if you go ahead and hit Control T, does anybody know what that's going to do? It's going to give you a split screen with a table and the graph. Okay. So let's say I wanted the 15th term. I mean, you can here go to Menu, go to Table, okay, Edit Table Settings. And if it's small enough, like you're looking for the 15th term, I can just type in 15 and see once again, that's going to give me the 22 right here. Okay. Or if it's something larger, you probably do want to type that in. If not, you can just scroll to it like we did here. Okay, so that's another way you could do that. There is also one other way to do this. Let me go ahead and get out of here. All right, so if we go to Menu, okay, we wanted, I forget, I believe it was list operations, correct? Yes, okay. So let me go back here so I can give you the right one. So if you go to Menu Statistics and you go to List Operations, Sequence, okay, well, what you want to do is type in your formula. In this case, we're using 127 minus 7x. So 127 minus 7x. Then you want to put comma, okay. You want to go ahead and put in the x. You have to identify what variable it is that it's going to be solving for. A comma is at the very bottom left of your calculator, right here below the pi button. Okay. And then what you can do is go ahead and tell it to go from what term you want to the last term. So let's say I want it to go from the first term to the 15th term. So I'm going to go ahead and type in 1, comma, 15, and then I'm going to go ahead and leave it like that. So whatever starts the sequence, once I push enter, see that is the first term. And if I go ahead and run through to the end, the 15th term again came out to be what? 22. So there's all kinds of ways that you could go ahead and do this. Okay. Now for that one, remember I went to menu, statistics, where'd I go? List operations, and then sequence. So you got to put in your function, basically your formula. You got to put in x because it has to know exactly what it's solving for. And then the values you put in are the term numbers, where you want to start and where you want it to finish. And it'll go ahead and list those for you. Okay. So good. Again, some more operations on the calculator that could be very, very useful to you when you get to those paper exams. Okay. And that's it on the calculator. Now let's talk about series. What was the difference between a sequence and a series? We kind of brought it up yesterday. There you go. A sequence was just a generated set of numbers, based on some kind of pattern. But if I start taking those numbers and I add them up, that's what we call a series. And see here, it gives you a sequence, just a random bunch of numbers. Okay, well, shouldn't really say random because there is a pattern. And then the series is when I take those terms and add them up. Okay, so let's see here. There's a formula. In fact, there's two different formulas that can help me out with this. We have one here where it's really very, very similar to the original formula we've been using for the nth term. A couple of changes here. We're going to double the first term. You see how I still have the n minus 1 times d? N is, of course, the number of terms. D is your common difference. But then that expression we want to multiply by the number of terms divided by 2. Now, there's also another variation of this, which we'll use in just a second. You take the number of terms divided by 2, but you multiply it by the sum of the first term. And what does u sub n represent? The nth term. So basically, you're talking about the last term that you're wanting in your sequence. Okay, whatever term you want to stop adding at. And it is possible to go ahead and add infinite sequences, but there are specific rules for those. And we might get into those a little later. But let's take a look at an example here. Let's see. Find the sum of 20 terms of this series. -2 plus 1 plus 4 plus 7 plus 10. Okay. And you can absolutely go ahead. 20 isn't a very big number. You could generate the sequence and then just add it up. Okay, but even at 20, I would probably encourage you just to use the formula. Okay, so we know n is 20. Okay, what's the first term? Okay, so that's u sub 1. Do we know the common difference?
3.
It is 3. Okay, to go from the previous term to the next, we're always adding 3. So d is equal to 3. So let's write out our formula. Okay, so the sum of 20. And that little subscript, when you have that capital variable s, that's telling you we want to take the sum of those 20 terms. Okay, so I'm going to take n divided by 2, and then I'm going to double u sub 1 plus n minus 1 times d. All right, we've got everything I need. We just need to go ahead and plug everything in. So s sub 20 would equal, and I can simplify some of this. 20 halves would just be 10, right? Okay. Or does anybody actually want to see me just write out the substitution? No? Okay. So then we have this. So this would be 2 times -2. So we're going to have -4 right here. Plus, now if 20 is in, then what's going to be my next value? 19 times 3. Okay. Is everybody okay with what I did? Okay. And now it's just a matter of putting that into your calculator and seeing what we walk away with. So let's see, 10 parentheses, it was -4 plus 19 times 3. Okay. And I'm getting 530. Is that what you guys are getting? That's it. That's all there is to it. So I guess you could say some of those problems are going to be just like that. Some. Okay. So 530, there we go. All right, questions. All right, now the next two are a little unusual. These involve a few more steps. Okay, so we'll just take it, one step at a time. The next one says an arithmetic series has a third term of 0. Okay, so I know that u sub 3 is equal to 0. And then it says the sum of the first 15 terms is negative 300. So I already know the sum of the first 15 is negative 300. Okay, what's the first term and the sum of the first 10 terms? So we're going to have to work backwards. So there's quite a bit that we have to do here. Now, my hint, it says go ahead and find u sub 1, the first term, and the 15th term in terms of d. Okay, and then we'll go ahead and start to go ahead and plug everything in. Now for this one, we're actually going to go ahead and use the second formula that I referred to, this guy right here. Okay, where we take the sum of the first and the last, and we multiply that by the number of terms divided by 2. Okay, so let me go ahead and get that formula over here as well. So n over 2 times u sub 1 plus u sub n. So that's the formula we're going to use for this problem. Okay, well let's go ahead and start with u sub 1. Okay, how am I going to write that in terms of d? Think about the formula that we were looking at yesterday. Oh, I'm sorry. That's u sub 3, the term that I have. Yeah, that might make a little more sense. Sorry about that, because we don't have the first term. We're trying to find the first term. Sorry about that. Okay, so how am I going to write the third term in terms of d, the common difference?
Could it be like increasing by 100 since the first term is negative 300, but the third term is 0?
Well, now we can't use that just yet. So think about the formula we had yesterday. We know that the nth term was going to be what? Does anybody remember? The first term plus n minus 1 times d, right? Okay. So we know the third term, u sub 3, is equal to. Now we'll go ahead and plug in what that's equal to in just a second, but I want to keep that there because we'll know the value of n. So we don't know u sub 1 plus, what should I put here for n minus 1? 2, because the third term, n is equal to 3, right? So this would be 2d. All right. But we know that u sub 3 is equal to 0. All right. So what would u sub 1 be in terms of d? Oh, so I was right. Yeah, I'm weird. So I was right to have u sub 1 in terms of that. Anyway, yeah, what's next? How would I solve that for u sub 1? Yeah, just go ahead and subtract, right? So we know that u sub 1 now has got to equal negative 2d. All right. So is everybody okay with what I'm saying now when I mean rewrite it in terms of d, the common difference? Okay. Now we're wanting to do something very similar with the other one. Let me give you 1 minute. Try to do the same thing for u sub 15. So I want the 15th term in terms of d as well. We're going to use a little bit of substitution here to help us out. Remember, this lesson we're being introduced to some new formulas, but it's really just kind of going back to just some algebra. So u sub 15. Anybody think they got it in terms of D? Okay, Eli, what do you think?
Would it be u sub 15 equals negative 2d plus 14d?
Which is 12D, yes. Okay, how many people got 12D? Okay. All right, if you didn't, okay, let's go ahead and see how we could do that. Okay, the formula that I just erased, u sub 15 equals, well, you take the first term, u sub 1, and then you would add, remember the n minus 1, but in this case, what's n? 15 minus 1 times d. So u sub 15 would equal the first term plus 14d. But remember, we already found u sub 1 in terms of d, so I'm just going to replace that with negative 2d. And see, that's where we were able to get the 12d from. So the first thing that I'm really trying to find in the problem is going to be the common difference. Okay. So now I can go to my formula. All right. I'm going to use this formula right here. Okay. We already know that the sum of the first 15 is negative 300. So I'm going to set that equal to, how many terms do we have? 15 divided by 2, and we would take the first term plus that last term. Okay. But take a look at what we have. Don't we already have those? The nth term is the 15th term in this case. So we're really taking the sum of negative 2d plus 12d. See, we found the first and the last in terms of the common difference. Okay. So somebody help me out. What is half of 15? 7.5. So negative 300 is equal to 7.5 times 10d. Okay. And you can go ahead and multiply through. What's that 10 going to do? Move the decimal, so that's really 75d, right? Negative 300 is equal to 75d. And go ahead and divide through. We should be able to get our common difference. So what's d? 4? Negative 4. There we go. All right, so now we have the d is equal to negative 4. Okay. So is everybody okay with what I've done so far? See, now this becomes a problem like we looked at yesterday. We have certain terms. We can go ahead and work backwards and figure out first what the first term is. Okay. Do you want me to give you some time to try that on your own, or do you want to do it together? What's that? Sierra, what do you think? Do you want to try it yourself, or you just want to keep working together? Together, okay. So let's see here. The first thing we want to go ahead and find, what is the first term? Okay, and here's the formula to find any term that you want. It was u sub n is equal to u sub 1 plus n minus 1 times d, right? Okay. Well, let's kind of think about everything we have. Do we have a term that we can actually use? Remember, we started knowing that the third term was what? 0. Okay, so we can go ahead and plug that in. We can go ahead and use the value of the third term equals. Well, we don't have any idea what u sub 1 is, plus what would n be in this case? 3, because we're using the third term. Okay, so that would be 3 minus 1. And we just found d to be negative 4. Yes? Oh, actually, you know what? Yeah, you could do that. I guess I was just thinking my way was more fun. Because it's gonna turn out to be the same thing. So if we did plug it straight in, negative 2 times negative 4 would give me what? 8. So let's see if this, in fact, gives me the same thing. Okay. And Eli, what were you saying?
Oh, I was just saying we're going to end up getting u sub 1 equals 8.
See, it's one of those things, you know, I typically have the unfortunate strategy of always choosing the most difficult way to do something. And then it's when I get to the end, I'm like, oh, I probably just could have done that. But I guess this is a way of kind of confirming that we're correct. Okay. So let's say, yeah, because this right here, 2 times negative 4, we know that 0 is equal to u sub 1 minus 8. Yeah, and then we go ahead and add the 8 over. Yeah. So we absolutely still get that the first term's got to be 8. Okay. All right. Well, would you guys like to try the summation by yourself? Okay. All right. Now, here's the thing. Let me go ahead and ask you a question real fast. Can I use actually either of these? I can definitely use the first one. Could I use the second one to do this if I wanted? There was just one thing you'd have to find. Well, we have the value of d, so we don't need that in the formula. I would need that. Well, no. See, the last term that we're going to add in the series would be the 15th term, right? So if I wanted to use the second formula, I would have to know what the 15th term is. So if I were to calculate that and use it, it's still going to give me the same answer. So I'm just showing you, there are options here. Okay. Okay. But I'm thinking a lot of people are probably just going to use this one. The n divided by 2 times double the first term plus n minus 1 times d. Okay. Because for this one, we actually have everything we already need. Let's go ahead and plug in the 15 for n.
Wait, isn't it the first 10 terms?
Oh, I'm sorry. This one we just want 10. You're right. You're right. Okay. Because we already know that the sum of the first 15 is 300 and negative 300. Yeah. No, I just ran out of. I was just writing past it. So we're still on that same problem. We only have one thing left. We want to find the sum of the first 10 terms. Okay, so I'm going to go ahead and plug everything in. I'm not going to solve it just yet. So S sub 10 is equal to 10 divided by 2. I'm just going to go ahead and put it in 5. We just found the first term to be 8. So 8 times 2 will give me 16 plus, what's the number of terms? Okay, it's 10, so 10 minus 1 would give me 9. And then we found d to be what? Negative 4. All right, so all I did was substitute everything in. Who can help me out with that sum? Okay, Eli, what do you think it is?
Would the sum be negative 100?
Okay, what do you guys think? You get negative 100?
Yep.
Okay. All right, nice. Does anybody want me to put it in the calculator to see? Yes, okay. So let's see. We got 5, 16, 9, and negative 4. So 5 parentheses 16 plus. It was 9 times negative 4, or I could just put in minus 36, whatever you want. Okay. And then there you go, negative 100. So that's the nice thing about these formulas. A lot of times it's going to be very straightforward. You'll have all your items. You just, any of your old teachers ever use that phrase, plug and chug? You ever heard that before? That's where you're just substituting in variables and simplifying the expression. Nobody's teacher ever said that before, really?
Plug and chug.
Plug and chug. You heard that around? Okay. I'm kind of surprised that hasn't been more popular, but okay. But yeah, a lot of times you're just using a formula for these. Okay. So negative 100. Perfect. Okay. Well, let's go ahead and try the next one. Now, if you like that problem, you're going to love this one. Okay, because this one becomes a problem, and in fact, the type of equation I don't remember if we've done one of these in here before, but I know you've seen them in Algebra 2. So it says a new business is selling home computers. They predict that they will sell 20 computers in their first month, 23 in the second, 26 in the third, and so on in arithmetic sequence. How many months will pass before the company expects to sell their 1,000th computer? Okay. So how many months are going to pass before they sell their 1,000th computer? Okay. So really here we're trying to find what variable? We're trying to find n. Okay. So I would go ahead and recommend that we use this formula to help me out. N divided by 2 times the sum of the first and the nth, basically your last term. Okay. So what all do we know so far? What's the first term? So u sub 1 is 20. What is the common difference? 3. They're going to sell 3 additional every month. Okay. Now, what I would go ahead and do is write out the last term in terms of n. Okay. So I want basically the nth term. Okay. Well, that would be u sub 1, which is what? 20 plus n minus 1 times what? Times 3, right? Okay. Now, all we're going to want to do is go ahead and plug in everything that we have. All right. So let's see here. N divided by 2 times, well, now we're going to go ahead and plug in the first term, which is 20, plus, now we have an expression for the last term, u sub n. So 20 plus n minus 1 times 3, okay? And now we want to know how many months is going to pass before they sell their 1,000th computer. So you can go ahead and set this equal to, I would think it's much more likely that you go ahead and change it to an inequality, because it says before they sell their 1,000th. So you're wanting it to be less than 1,000. Is everybody okay with that? But even if you weren't to do that, if you just put equals, you would be perfectly fine. Okay. So now we just need to go ahead and simplify this and see what we end up with. In fact, I was talking about an equation that I don't think we've gone over yet in here, but you have seen in Algebra 2. What is this going to ultimately become? Okay. What's that, John? Well, we want to be less than 1,000. We want that sum to be less than, but I'm talking about the equation. What's the model that we would have here? Like what graph would fit this really well? Not exponential. And if you were to tell me, you would parabola be right. Quadratic, a parabola. Did you get my subtle little hint? If you were to tell me, you would parabola be right. Once again, Mr. West knocks them dead. There we go. Okay, so let's simplify this. Okay. So let's see here. This would become 3n minus 3. Is everybody okay with that? All right. And now let's just go ahead and simplify what we have inside. So n divided by 2. What's my constant? 20 plus 20 minus 3? 37. And then we have the plus 3n. Now this is less than 1,000. Okay. So I would, yes?
If you multiply both sides, might you get rid of that?
Yeah, I'd go ahead and now multiply through by 2, and then I would go ahead and distribute this, and you'll see that's where your quadratic is going to come from. So to get rid of the fraction, I'm going to multiply through by 2, but because this is already a product, see, I'm not needing to distribute the 2 across that group. So this is just going to be n times 37 plus 3n is less than 2,000. See, technically, I already multiplied the 2 across this group because n over 2 is multiplied against it. So I don't need to multiply by every one. Does that make sense? Okay. And then do a little bit of cleanup here. So this would be 3n squared plus 37n is less than 2,000. Let's go ahead and pull that over. Excuse me. And there is, where's my tea? What did I do with my tea? Oh, it's right here. I need a drink. Now you're going to have a calculator. If you want to solve this by hand, I mean, I can go ahead and walk you through the process. What do you guys remember about quadratics?
You can factor them.
You can absolutely factor them. This one's not factorable.
Well, then who?
Yeah. Okay. There we go. Okay. So what's a very famous formula we could use? Quadratic formula. We could complete the square. Or if you just want to use technology, we could use the calculator to get the answer.
Well, let's use the calculator.
Okay. Now, if you want, I can go back and show you that. In fact, does anybody remember the quadratic formula?
Minus the square root of 40.
Okay. And how many people were like, the opposite of b plus or minus the square root, b squared minus 4ac, all divided by 2a.
No, did you ever look at quadratic formula songs? Negative.
Well, mine was just kind of set to a melody.
B squared minus 4 raised to. Okay. There's a song
Oh,
Mr. Ubis and Hutch taught all of the kids.
okay.
We
And you remember it.
for you. I'll never be able to forget it.
There you go. There you go. All right, so let's go ahead and see what this is. Okay, so I'm going to go to my calculator out here, my scratch pad. Now, of course, I'm going to go ahead and use x instead of n. So I'm going to say it was 3x squared. What was that? Was it plus or minus 37? I can't remember. Plus 37 minus 2,000. Okay, so plus 37x minus... Now, before I even go ahead and push enter, just help me remember a couple of things. Would this parabola open up or down? Why up? There you go. It starts with a positive. What is the y-intercept? Negative 2,000. So it's way down there, right? Okay, so let's go ahead and push enter. See, we don't even see the graph yet. So what I'm going to do, you remember there was another time earlier today I went ahead and showed you Zoom Fit. You could use that if you want to, or the other option that I mentioned for Windows Zoom, you could go ahead and just zoom out. So there we go. So we know the parabola is opening upwards. Now, we don't need to see the entire parabola in order to do what we're about to, but which one do you think I'm going to want to focus on? Why the right side? What's wrong with the left? There you go. Now, in terms of our problem, our real-world situation, we can't accept that answer because it's negative, so it wouldn't be reasonable. So the only one we're looking for is this guy right here. So I'm going to go to menu. We want to analyze the graph. Now, which one am I wanting? 0, minimum, max, intersection?
0, right?
We want 0 because we're looking for where it crosses what? The x-axis. If we were looking for the intersection of two graphs, then we choose the intersection. Okay. So there we go. So were any of you ever shown this in Algebra 2? Yeah, there you go. Well, that's okay. That's okay. That's what, we're doing this. So you see how it says lower bound, and it gives you this little vertical line with what looks almost like a text symbol? Okay. All it wants you to do is mark a location to the left of what you're trying to find. So I'm going to put it on the left side of my value. I'm going to push enter, and it immediately says what? Upper bound. As soon as I slide it to the right, it's going to create a shadow region. When the shadow hits that root, it's just going to pop up the answer. So about how many months will it take for them to sell their 1,000th computer? 20.4. Oh, now when you push enter, it'll say upper bound. Then you just move your mouse across. Do you want me to go through that again? Let me find it on this other one. Menu, analyze graph. We want the 0. So let's say I want this point right here. So I'm going to put my line left of what I'm looking for. I'm going to push enter. Then it says upper bound. As soon as I move him right, see, it creates the shadow region, and it'll immediately pop up that coordinate. Yes? No. In fact, on this, I've actually seen it. You can go way far left, and it'll still go ahead and do it. I've even seen it where it'll work for multiple points at once. Okay. So there we go, about 20.4 months. Does that make sense? Any questions? Okay. All right. Good, 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 good. Well, there is only one aspect left, and then this lesson is in the books. Okay. Sigma notation. Okay. It's capital epsilon. Now, that sigma stands for the sum of. So that's a little mathematical notation that tells you you're wanting to take a sum based on whatever function you happen to see here. So the lower number, okay, the lower boundary, that is the term that you're starting with. The upper is the term you're going to end with. So you'll notice this one is already worked out for you. Now, here they typically use I, but does the variable matter? Now, the variable can be whatever you want it to be, x, n, any of the ones we've been using. But here's my function, 2 plus I. So one at a time, you see I plugged in 1. Then I plugged in 2, 3, 4, all the way to 5. So I went all the way to my upper boundary. And then I just took the sum of each of those values. Okay. So the summation of 2 plus I from 1 to 5, well, that turned out to be 25. Okay. This is another way to find a summation. All right, so let's go ahead and do this one. Find the summation of 5 plus 2i from 1 to 5. Okay, well, the first term would be 5 plus 2 times 1 is 2, plus, then the next parentheses would represent the second term. So I'd have 5 plus 2 times 2, 4, plus, now we're on the third term. Again, 5 plus 2i, but 5 plus 2 times 3, 6. Plus, and then I would just continue that pattern for however long it wanted me to go, to whatever term. Okay, so I've got to do it 2 more times. This one would be 5 plus 2 times 4, 8. And by now you probably already noticed the pattern. 2, 4, 6, 8. So the next one's got to be 5 plus 10. Okay, so this would be 7 plus 9 plus 11 plus 13 plus 15. And somebody help me out. 55. Okay. There you go. Now, I know what you're thinking. That's great. It's not very difficult. Again, if it's a very small number, you can easily do it like this. But what if it wanted you to go to like, 100 or something like that? You probably don't want to sit here and write that out 100 times, right? So let's see how to do it on the calculator. Okay. So let me get out of here real fast. Okay, so I'm going to document B. Okay. So if you go to your home screen, well, actually, what am I doing? I need to go to my scratch pad. Now, you notice right here, that button we've been using for the matrix back in chi-squared right here between 9 and the catalog. If you push this button right here in the middle, there's your sigma notation. Okay? So when I go ahead and click that, it's basically fill in the blank. Now you can use whatever variable you want. Like here, we started with the first term. We went to the fifth, and our formula, what was it, 5 plus 2i? So I'm going to type in 5 plus 2x. Okay? And what did we get for an answer? Remember, we got 55. So if I plug in all the appropriate values, it'll automatically give me that sum. Okay. Remember, where did I find that? There you go. This button right here between 9 and the catalog. It's in the second row right next to your matrices. Okay. Now, here's what's also really interesting about this, and we're just about out of time, but could I use, instead of just the pattern, could I use one of those summation formulas that we just looked at to help me with this? Yeah. Like, for example, if I wanted to use this one here, n divided by 2 times u sub 1 plus u sub n, I just need to know the first term and the last term. Okay. But there is one thing that's a little different about this. If you're going to use a formula, you're going to subtract the 2. You'll take your upper minus your lower because you're looking for n, right? So you'll take the upper minus the lower, but that gives me what? 4, but that's not the correct number of terms. I want the first all the way through the fifth. So if you're doing it by hand, you subtract the upper and the lower, but then you always add 1 back on. Okay. Because you don't want to subtract off the lower term that you're actually starting the summation with. Does that make sense? Okay. All right. Good, good, good. And we just got done. That was perfect. All right. All right.